Hello everyone, welcome to today's webinar and thank you for joining us. My name is Neil Foley and I'm the Applications Engineer at RISE. Today I'll be discussing how the increasing flexibility of 3D printing technology can be leveraged to provide value across multiple educational environments. So there are a lot of different types of challenges that can be posed to 3D printing in education. For example, typically education involves many different disciplines which have different needs for the type of things they may be interested in 3D printing. Some departments may care more about functional materials that have strength or perhaps specialized material properties. Other departments may care more about the appearance of parts. They want to make sure that it has a good surface finish or the ability to produce color or things like that. And still other departments may care primarily about the precision of parts and ensuring that they stay within tolerances or are able to develop very fine features with high accuracy. Another challenge posed is the fact that in educational departments, the production schedule of the 3D printer is it's at odds in some cases with the schedule of the educational year. So in a lot of cases, everyone who needs to use a 3D printer comes to it at the same time because there are periods during the educational year when all assignments start reaching their due dates, especially near the end of semesters. And this can create tight bottlenecks where people are not able to access the 3D printer when they most need to because there's such a high demand for it. Another challenge to 3D printing in education are the regulations around safety and sustainability. And one of these that is particularly problematic is the fact that so many 3D printing technologies can pose harmful atmospheric effects where as the printer is used, it is releasing various dangerous chemicals which need to be vented and carefully regulated. Another challenge is the fact that typically educational departments have a focus on providing to their students a set of various experiences that they will be able to apply once they graduate and enter the professional field. And for this reason, it's often valuable for educational departments to provide a variety of technologies so that students get experience in different things that they may end up using so that they are not surprised with a new and unfamiliar technology when they reach a professional field. Another thing that, of course, educational departments will be concerned with is the cost upfront and ongoing of buying and owning a 3D printer. And this, again, is beholden to the educational calendar, which typically requires that educational departments have a set budget that can be spent only within a certain period of time. And because of this, there are restrictions on the type of technology that they can invest in. Another important thing, of course, related to the bottlenecks and to the fact that there is a oftentimes 6-month or less restriction on the period of time that students will be using a printer is reliability. There can't be 2 or 3 months that a printer is not working, or else there is an entire class of students that will have missed out on being able to learn to use it and learn the lessons that can be learned from using a 3D printer. And finally, a few more things are that because there are so many different possible users of 3D printers, if students of an educational department all have access to a 3D printer, there can be a very large number of parts with many different students holding claim over them, and this can make it very difficult to sort through the parts and make sure that they reach the right people once they've finished printing. And finally, because there are so many students possibly using a printer, it can be challenging to train each new class of students and make sure that a printer is easy enough to learn and to use, that they won't spend the entire semester just getting the basics and never really harnessing the full capabilities of a technology. So next, I'm going to talk a bit about what RISE does specially. So we have a patented technology that we call augmented polymer deposition. And this is a technology which combines the extrusion of thermoplastic polymers and the jetting of different functional inks from the type of inkhead that you would find in a 2D printer. So as you can see in this diagram, the way our process works is that first we will extrude our thermoplastic material, and then between each layer of extruded thermoplastic material, we have the ability to jet different types of inks. In this case, we've listed release ink and marking ink. And the, the process will typically begin with extruding support, followed by release ink, which is an agent that allows supports to be easily removed from the rest of the part. Then you will continue to extrude and produce the structure of the part itself. And between each layer of the part, you're able to jet additional inks, and these can be marking inks, either for different adding different color or information to the part, or they can be other functional inks which can perform a variety of different can provide different benefits to the part depending on the requirements of the user. So some of the specific challenges that are posed to education involve, as I mentioned, the fact that when there are so many possible users of a machine, if you have a large class or department of students that all need access to it, it can be challenging to keep track of which parts are destined for which students, and make sure that when a student receives a part, they are the one who the part was intended for, and that students aren't either mixing up parts or taking parts that aren't theirs, and so on. Another fact is that it's difficult to produce both strength and visual effects in 3D printed parts, because technologies typically need to specialize in one or the other, or in some cases other factors. So in the departments that care primarily about the visual effects of 3D printing, such as marketing departments or art departments, one issue is that the printers that are capable of producing the visual effects that they need often lack the strength and physical properties required to make those parts durable. And in some cases, such 3D printed parts produced for these departments can be fragile and break prematurely. So one of the solutions that RISE has offered regarding tracing and authenticating parts is the ability to use our marking ink ability to add text or QR codes and various other information to the surface of a part. So using this ability, you can attach all sorts of different information, especially onto a QR code, which allows you to track student names, their registration number, the date that the part was submitted, and all sorts of other metadata about the print. This is useful not only for tracing and authenticating parts, but it can be useful for all sorts of other things, such as applying instructions to the surface of a part to provide information about how to use the part or how to assemble it to another part, or even to connect it over the internet to a model file that identifies where the part came from and how it's to be used. So as I've alluded to already, some of the benefits of the RISE machine and our APD technology are that depending on the types of inks that we jet in between layers and the types of polymers that we can use, we can achieve a very large amount of flexibility in what our printer can do. So the printer that we have coming out later this year, called the XRISE, is capable of producing carbon composite prints as well as full color functional parts, because we are able to maintain the strength and durability of thermoplastic filament printing, but we are able to also use full color because of our inkhead process. So this is this capability of producing functional full color parts is useful for a very large number of applications and can be applicable to many different educational departments, as you can see here. So life sciences can produce accurate medical models that will endure for longer than you might find with other 3D printers that can produce full color. There are, as said here, geography, geology, and architecture can benefit from producing both architectural designs and maps of different areas that can store not only the information about the color of the land, but text as well, legible text that can be used for teaching those types of classes as well. And then there's product design, which of course would benefit from both strength and color, and engineering, which benefits not only from the full color, but from the strength offered by our carbon fiber infused filament. So another major challenge for education and for even professional industries as well is that many of the typical situation for thermoplastic filament printers, as discovered in a 2-year study released by the Georgia Institute of Technology, is that most filament 3D printers produce over 200 volatile organic compounds, and these are often irritants and carcinogens and other bad things from each 3D printer. And when these 3D printers are placed in a living or working area without thorough ventilation and precautions taken to ensure that the dangerous chemicals that are being emitted are handled, this can be quite dangerous to the health of the people working around those things. And so this is a problem particularly for places that have a lot of students moving in and out that can possibly be exposed to dangerous chemicals like these with not even realizing it. So the solution that RISE has found to this problem is that we have developed our own proprietary material called Risium-1, which has a lot of useful properties. So on this page, you can see that it is it's an engineering plastic. It is produced with medical grade materials, and because of that, it's approved for contact with both skin and food. It's quite strong, and whereas one of the major problems with a lot of thermoplastic filament printers is that while they can create high strength parts in the horizontal direction, it's often difficult to create parts that are strong vertically because the layers that are extruded are difficult to fuse well and often come apart. That's the typical point at which parts will break along a layer line. So in the case of Risium-1 and our future Risium materials such as carbon infused, our material fuses very well from one layer to the next, which gives it a 90% isotropic strength. So the z-axis is 90% as strong as the x or y-axes. Another valuable feature of Risium-1 is that it's got very low moisture absorption. So whereas many 3D printing materials need to be stored carefully to avoid degradation due to absorption of moisture in the air, Risium can be left out and there won't be any issue if you leave it exposed to the atmosphere for months at a time, and it will still maintain its quality. Now, one of the most valuable benefits of Rhizium is that whereas typically when you extrude filament, the temperature at which you extrude the filament is hot enough that it is decomposing the material, and that's what's producing those irritants and carcinogens. We are able to extrude Rhizium at a much lower temperature than the decomposition temperature. And because of that, it doesn't produce any harmful chemicals, and it doesn't need to be vented at all. It's won an award recently for best practices in technology innovation in the zero emission polymer material additive manufacturing industry. And one other valuable point about Rhizium is that it's totally recyclable. You can toss it right in the bin and it will be taken care of. And because of that, it adds a component of sustainability that will be valuable for schools that are going through a large amount of material due to use by a large number of students. And a final challenge that is posed to educational departments with 3D printing is that of logistics. Because there are such a large number of students who may be interested in using 3D printers, it's important that the 3D printer is either simple enough to use that those students can quickly be trained on it and get started with printing, or there needs to be a lot of infrastructure for students to be trained extensively on a harder to use 3D printer. So because of that, it's important for RISE that we keep our process both before printing and after printing very simple, so that there isn't a lot of overhead in terms of training students before they can jump in and start getting useful experiences out of using their printer. And the other point, as I mentioned earlier on, is the fact that there are bottlenecks in the educational calendar, particularly around the end of semesters, where many students all at once will be vying for access to a 3D printer. And because of that, 3D printers need to be very reliable, and they need to be able to produce parts quickly and without a lot of post-processing that would sort of jam up the systems in place. So the value that RISE offers on this point is the fact that because we are able to jet the release ink in between the support and model structure, which makes it very easy to remove supports, this makes it so that the post-processing of parts can be limited to a few minutes or even a few seconds, because the supports will pop right off and the part is ready to use. So you don't need to worry about soaking the part in a chemical bath to dissolve the supports. You don't need to worry about then washing and drying it. You don't need to clean off any powder or residual material, and you don't need to coat it with any sort of binding agent or other chemicals. So because of that, the time to part is limited essentially to the time it takes to process the part, put it on the printer, and get it printed. And you don't have to think too much about how long it's going to take after that. And because of this, a student can, in some cases, get their part from concept to in their hand within a single day. And this can rapidly speed up the design process, which is, of course, very important when they're on limited timelines before the end of the semester. Some other values of the RISE process are that we have developed our own proprietary software, which we've done our best to automate. So because of that, you don't need to have a lot of experience with processing parts to be printed. Our software will make the important decisions to make sure that your parts are handled in the best possible way without needing too much input from the user. Additionally, our printer has very little material management or maintenance required. You don't need to change the printing tips. You don't need to do a whole lot of cleaning on it. Just a simple wipe now and then is plenty. And because of that, students can be using it one after the other without there needing to be many stops for someone to go through and prepare it for the next batch of prints. So now I'll talk a bit about one use case that we've had for our technology by a student group. So this was a FIRST Robotics team that decided to use the RISE technology to produce a part for one of their robots. And what they were able to benefit from using the RISE is that not only did it provide strength and durability, as you might find in many different FFF or FDM technologies, they were also able to use the marking ink technology to differentiate among the different versions of their parts, which allowed them to more easily track their development and the iterations of their designs. And that helped them more quickly reach a working solution, and it turned out to be quite successful for them. So here is an image of the part in its context, in the context of the robot. So it has several different pulley sections as well as a sprocket connected to a chain. And this was printed all in one piece and marked up on the sides, as you can see. So the purpose of this robot was to collect boxes, move them across a gymnasium, and stack them in a controlled manner. So now I'll just quickly review some of the things I've talked about today. Some of the values of the RISE one that would be particularly valuable to educational departments is, whoops. Sorry about that. Some of the values of the RISE 3D printer that would be particularly valuable to educational departments is the fact that it is very safe. It doesn't emit any harmful chemicals. The material is both recyclable and medical grade, which makes it safe to handle. It's also a very simple machine to use. It's simple both in terms of the software that's used to prepare parts to print, as well as the process of using the printer and then post-processing the parts once they finish printing. Because of the simplicity on both ends, it's much faster than other technologies which would require a lot of post-processing or a lot of expertise in pre-processing. And it also is a very functional material that is very strong in the Z direction, and this allows it to be used for a variety of different applications without as much concern for orientation of parts as you may need to consider in other technologies. And then the last thing I wanted to mention is that we do have a special going on right now where if you order an X-Rise, you will also receive a RISE 1. So the RISE 1 is the monochrome printer, which only uses blue marking ink, and the X-Rise will have full color capabilities. So that's all I have for this webinar. Thank all of you for joining us. If you have any questions, you can add them into the chat box at the bottom, and I will answer them for a few minutes. If you have any questions unrelated or that you perhaps need a long form answer to, you can also message us at applications@rise3d.com, and I will be happy to get back to you. So I will stick around now for a few minutes, and if anyone has questions, you can add them to the chat window, and I will answer them as they come. Thank you again for joining us.